This is FE Peer Review. The date is December the 15th, 2021. Taboo Conspiracies Denali photo is the black pool of the Pacific. Our favorite Mr. 42 put out a video reviewing some material by Taboo Conspiracy in which he tries to conflate perspective and orthographic imagery and to turn it into his own special way of depicting space. This is a subject I covered myself some time back, some months back, maybe last year. And I don't need to get into that, but I wanted to bring this up. Well, first of all, to encourage people to go see Mr. 42's video if you haven't already. It's a very fun video. And also to look at this picture, which Taboo Conspiracy used in the background of his video. What we are seeing is a mountain in the background, and we're going to look at a better copy of this in a moment. And that's Mount McKinley, also known as Denali. Very interesting choice of image. This here is the original. It was a photo taken by Josep Manchado, and it was around 2006 or something. It was quite a while back. Anyway, I was able to track down this original photo and also able to identify where the photo was taken from. At least I'm pretty sure about that. So we'll look at that in a minute. Well, what we've got here are some screenshots I took from Google Earth to try to locate a few of these key locations. So we have Anchorage down at the bottom. I've made a path in Google Earth with the red line. And we've got Denali up at the top. We see here the airport in Anchorage, Alaska, and a small parking area, kind of vista point off towards the top where that red line is. This is, I believe, the location where the photo was taken from, this parking lot here. And this is the street cam, the street view from Google Earth of that location, and you can see my red path marked in there. So the cameras that they use on those street cams are not good enough quality to capture the view of the mountain off in the distance, but it's in there with those clouds, right where that red line ends. Go back and look at the original. That's the opposite shore of the water at Anchorage and the tree line and mountains beyond. And here we're saying that same water and those same trees. So that's our location for the observer, and that's our mountain up at the top. There's a closer view of the mountain from Google Earth. I've just navigated in there following my red path. And we're going to look at the key points in this range here to identify some elevations. Denali, also known as Mount McKinley, has an elevation of 20,310 feet. And Mount Hunter has an elevation of 14,573. This little peak over here is Mount Hunter. The tallest peak is Denali, and this piece that comes off to the left of Denali and then drops down, that is called the West Buttress. So we see Denali here, the West Buttress, and Hunter. Now what I've done is that trick of overlaying the one image on another and then using the opacity bar to show that I've got a pretty good alignment of the images. So we see there the Google Earth image, and really only need to focus on the profile line of peaks. All of this stuff down in the foreground is not of our concern at the moment. And we're going back to the photo again. So there's the photo. And there's the Google Earth image, about 50% opacity. All right, now we'll move on. This is a snippet from a topographic map from the US Geological Survey that shows Mount McKinley and the West Buttress. Mount Hunter is off the bottom of the page here. So Mount McKinley, we see a dark blue line. Let me change my cursor here so it works better. We see a dark blue topographic line. That's marking 20,000 foot. That's a 20,000 foot line. and the peak is at 20,320, according to this very old topo map. This map is from the 1950s, so apparently the height has been revised downward to 20,310 since this map was made. The next dark blue topo line is 19,000 feet, and then the following one is 18,000. We can follow the 18,000 foot line around. So continuing to follow that 18,000 line, we come around, and now I'm right at where it says Denali Pass, and we have 18,000, 17,000, 16,000. We have this 16,000 line coming out and cutting back in again. And then we see that it drops very quickly from there, 15, 14, 13, 12, 11. So what we're seeing here is the west buttress, which has a steep drop. If we look at the photograph again, we see the steep drop right here. So that's the buttress, and that's the peak of the mountain. The peak is at 20,310, and we're going to take a look at the elevation of that buttress. Here's another view from Google Earth. We see the mountain, the peak, and off to the side, the buttress with this steep slope coming off of it. Now let's go over to Google Earth and get an elevation of that buttress. Here's the peak. And the buttress is right here. This is the ridge of that buttress, and it ranges on the right side from at 17,000, and as I move to the left, most of it is at around 16,000. So there's a jump up right here, 17,000, then it drops down to 16, stays at 16 all the way to where I have the pin, and then it drops down very quickly from there. Now, our line of sight is this red line, and Denali and the west buttress are almost exactly the same distance from our observer location, the two. Mount Hunter is a little bit closer. You can see Mount Hunter down here in the center bottom of the image. So we're not actually going to consider Mount Hunter in terms of its distance since it's closer, but it does come up in the image, and it makes an interesting contribution. So I wanted to point out that it's a little bit closer. So let's go back to this image here, and let's do a little thought experiment with it. Taboo conspiracy, if you're watching this, you can give this a thought. Imagine that you're like up at the top of the mountain, and you're going to drill a hole straight down between your feet, straight down to the bottom, so that the bottom of that hole is at the same level as the water here that we're standing near. Now, normally when we look at these mountains, we're aware that the base of the mountain is much closer to us than the peak, which is very true. And that can kind of confuse the issue sometimes about how these things are related to each other, us, our viewpoint, the horizon, the mountain, etc. So just set aside the idea of the base of the mountain and just imagine that you've drilled a hole straight down from the peak, 20,320 feet deep. Where would the bottom be in this image? That's what we're trying to figure out here. So what I did was I drew these two red lines. One is at the top of the mountain and one is at the west buttress. So 16,000 feet and 20,320 feet. So they're 4,320 feet apart. Now, interestingly, the top of the west buttress at 16,000 feet appears to us in this image to be the same height as the top of Mount Hunter, which is some 1,500 feet lower than the west buttress when we look at the topo map that we saw earlier. But because Mount Hunter is quite a bit closer to us, it appears higher. So that's one of the reasons why I didn't bother actually including its measurements in this analysis, but I just thought it was kind of an interesting thing the way that they lined up. So what we'll do, though, is we'll take these two red lines and we'll use them like a scale, 4,320 feet. And we'll just use that and scale downward to figure out where the bottom of our 20,320 foot hole would be. So I'm going to duplicate them one at a time. I'm going to duplicate them and just move them down. So we're moving the first set of lines down. There, that's 4,320 twice. We'll do that again 3 times. That takes us to 12,960. Do that again. Now we're at 17,280. We'll do that one more time. And this is going to go too far, but that's okay. Gives us an idea anyway. So there is 22,600 feet. So we were talking about a hole that's 20,320 feet. So it's going to come down to, round about where I've got the mouse, roughly speaking. If that bottom of that hole was down there and we could sweep everything away, is that where you expected the bottom of that hole might be? Taboo Conspiracy, if you happen to see this video, I asked you a question a few minutes earlier. Where do you think the bottom of that hole would be in this image? And using this approach, creating a scale from the difference between these mountain and the west buttress, this is roughly where we find it would be using that scale. How does that fit with where you thought it might be relative to where the horizon is? Now, in an image like this, it's hard to talk about the horizon because of the profile of the mountains, but if that could all be swept away, where would the horizon be in this photo? And where would the bottom of that hole be relative to it? Just a little thought experiment, but I thought you all might find it interesting. Bears some interesting resemblances to the Blackpool photo that we've seen in the last year or so. Hope you all found this interesting. Wish you all a very nice day, and see you again next time.